the objective for today's lesson. Okay, we will be able to explain the relationship between energy, heat, and work, distinguish between exothermic and endothermic processes, distinguish between heat capacity and specific heat or specific heat capacity. Okay, one of the terms is heat. The symbol we will be using for heat is Q. I know maybe in physics you use capital Q. In chemistry we use lowercase. Sorry for the confusion. Okay, so we have Q for heat. Is the energy that transfers from one object to another because of a temperature difference between them. I need for you to remember that heat flows from hot to cold. Heat flows from hot to cold. That's why when I went home yesterday, it was hot. When I got upstairs, it was hotter than downstairs, because that hot air is less dense. Okay, because it is less dense, it will rise. So the upstairs was hotter. So remember, the symbol is Q. Why don't I give you the formula for heat right now? So write it down. Q, which is heat, equal mass time specific heat. Sometimes you don't see the P, specific heat, time change in temperature. Okay, heat equal mass time specific heat time change in temperature. So that change in temperature is final temperature minus initial temperature. That temperature can be either in degrees Celsius or Kelvin. It does not matter, because the change will be the same. Okay, so let's move on. All right. Another term is thermochemistry. Thermochemistry is the study of energy changes that occur during chemical reactions and changes in state. Thermo, heat, and then chemistry, you know what it is. So let me give you two terms right now. Write down endothermic. Endo is heat is absorbed. Endo in thermic, heat absorption. Heat is absorbed. And for an endothermic reaction, we will use a positive heat. The heat will have a positive sign. Exothermic, exo, exit, out. When heat is released, the reaction is exothermic. We will say it is negative. Even though I want to make sure you understand, heat is not positive or negative. By convention, the sign just shows the direction of the heat. It is not it is positive or negative, just to show that heat is absorbed or released. Potential energy is energy stored in chemical bonds of a substance. I know in physics you learn potential energy is energy of position. Okay, potential energy in chemistry, we will say it is the energy stored in chemical bonds. Kinetic energy is energy of motion. Kinetic energy, energy an object possesses by virtue of its motion. Why don't we write two formulas for those? The potential energy, which we won't be using in chemistry. Okay, potential energy equal what? Mass time acceleration due to gravity time height. Kinetic energy that we may be using, kinetic energy equal 1/2 times mass time velocity squared. Okay, 1/2 mv squared. Let me derive the unit for energy for you. Okay, kinetic energy, any energy, mass in kilograms times, we have velocity is meter per second, and then because it is square, all right, it is kilograms times meter per second squared. And I'm sure you don't want to use your unit like that. So 1 kilograms times meter times second squared, we will call it a joule. Okay, so a joule is 1 kilograms times meter per second squared. It is the SI unit of energy. SI, it is French. It is le système international d'unité. The SI unit for energy is joule. But I'm going to add another unit right now. Is calorie. How do we convert from joule to calorie? So I need for you to write 1 calorie equal 4.184 joule. So you will be using this to convert from calorie to joule. 1 calorie equal 4.184 joules. When you see a capital C for calorie, it really means kilocalorie. Kilocalorie. So when you read the nutrients, the label from your food, you have to check to see if it's a capital C. When it says 5 calories, they really mean 5,000 calories because the capital C stands for kilo. All right. More key terms coming up. So show me those terms. We already said in an endothermic process, the system gains heat and the surrounding cool down. What is a system? System is whatever you are interested in, whatever you are studying. If I'm studying a piece of lead in a beaker of water, the lead is my system. Everything outside that system is the surrounding. Whatever is under study is your system. Okay, in an exothermic reaction, exothermic process, the system loses heat and the surrounding heat up. So endo and exothermic, remember to complete your Venn diagram from the journal packet. So what do they have in common? Both of them have to do with heat. All right, what is heat capacity? Heat capacity, usually it will be the capital C, is the amount of heat required to raise the temperature of a substance by 1 degree Celsius or by 1 Kelvin. I put both because a change in temperature is the same in Kelvin and in calorie, or in Kelvin or degree Celsius. Okay, heat capacity, the amount of energy required to raise the temperature of a substance by 1 degree Celsius or 1 Kelvin. What is specific heat? Sometimes they just say, they call it specific heat capacity or just specific heat. Is the amount of energy required to raise the temperature of 1 gram of a substance by 1 Kelvin or 1 degree Celsius. So heat capacity for any amount for specific heat is for 1 gram. That's why you multiply it by the number of grams to get the heat. I need for you take a minute, go pause the video, go get a calculator. Let's see if we can solve some problems. It said the temperature of a 95.4 grams piece of copper increases from 25 degrees Celsius to 48 degrees Celsius. When the copper absorbs, this is Q, 849 joules of heat. What is the specific heat of copper? So what I would do, I would write the standard formula for heat, which is Q equal mass time specific heat time change in temperature. Okay, sometimes we call it MCAT. Therefore, I'm not solving for heat because they gave it to me. I'm solving for specific heat. Specific heat equal heat, which is Q, time the mass time the change in temperature. Therefore, my specific heat equal the heat, which is 849 joules, the unit for heat, over my mass, which is 95.4 grams, times the change in temperature is my final temperature, which is 48 minus 25. Okay, equals, I'm sure since you have the calculator, you already have the Answer for me. 0.387. Let's see how many significant figure. How many significant figure here? It is 3. Significant here, 3. And this is 3 all over. And this is 3. Now, let's check the unit for specific heat. The unit for specific heat is joules per grams degrees Celsius. Unit for specific heat is joules per grams degrees Celsius. Okay, let's use our magic mirror to see if we have the right answer. Specific heat of copper 0.387 joules per grams degrees Celsius. Okay, good job. So I hope you have a great time. Thank you for watching the video, and make sure you complete your homework. Okay, so I'll see you next class. Take care.